Hello, good day everyone. I am Erica Pikayagan and I will be your micro teacher in this video. This is still lesson 8 analysis, interpretation, and use of test data, guys. No? So I hope you will learn more things in this video. So we already tackled about the central tendency, which has the mean or average, median, the middle part, and mode, which is the most frequently used score or numbers in the test data. We already know the scale of measurement that have nominal, which you and nominal, ordinal, interval, and ratio. So we know that nominal is a identification purpose. You say 1 and 2. So 1 is red, 2 is blue, like that. We can also see it in color, like a coloring book. No? So our ordinal is ranking. So it's ranking like your grades, who is has the highest grades, first honor, the second honor, like that. Interval is the interval between two numbers, like 4 and 5, that has the same distance, no? So a ratio has a true zero, and they said it is the most highest level of measurement. Next is the skewness, which has positively skewed, negatively skewed, and symmetrical. So we thought that positively skewed has more students, or more population of students have score higher. But no, the meaning is quite opposite. There are more students get lower grades than negatively skewed. No, their meaning is quite opposite to their name. So negatively skewed has more students pass, while symmetrical or symmetry has the that most student get the average scores. Next is the dispersion or measure of dispersion. We have the highest peak was A, while the middle peak was B, and the lower peak was C. So measure of dispersion, no, it's spread, scatter, or variability of the data points in the data set. So it measures how much the data points differ from one another, no? So that's why it has this curve. The highest point of curve is A, the middle curve is B, and the lowest curve is C. So range is that the highest score is subtracted by the lowest score. Next, we also have the standard deviation, which has already been tackled by teacher Joy, no? We have known how to do standard deviation using formula and Excel, and we also know the measure of position. So measure of position have quartile, decile, and percentile. So quartile dividing 4 halves equally, decile 10 halves equally. So as it said there, no? So like decagon, which has 10 sides if it's a shape. No? And then percentile, like a percentage, divided 100 parts equally. And now we are at the normal distribution. So normal distribution, how is the standard deviation applied in a normal distribution? So this standard deviation is viewed as the most useful measure of variability because in many distribution, of course, not only in assessment, but in research as well, it approximates the percentage of scores that lie within 1, 2, or 3 standard deviation from the mean. So, as it said, the most useful measure of variability. What do you think in mind? No? Let's answer it in the next slide. So, the answer is that because it includes all the data points, providing a comprehensive measure of how it is spread out no? And then the sensitive to every deviation from the mean, capturing overall variability, facilitates comparison across different datasets and variables, supports statistical techniques like hypothesis testing also and also probability estimation, if I am right. So next, it's that it underpins the empirical rule in normal distribution, aiding a prefer in the interpretations of normal distribution. So widely used in practical fields. So widely used daw siya, no? So overall, in summary, because the standard why is the standard deviation the most useful measure of variability is that it incorporates all the data points, offering a complete picture in how the data is spread around the mean. Its sensitivity to every deviation, which it makes it precise indicator in the overall variability. In addition to that, standard deviation enables the meaningful comparison across the different data sets and variables. So it's not variables, and it also supports, we should not always remember, it also supports the statistical techniques, which are the statistical analysis that includes the hypothesis testing and probability estimation. Its rule, its rule and the empirical rule helps interpret data within normal distribution, kind of essential such essential tool. This is also an essential tool in various fields. That's why it is widely used. So in various fields, what are these fields? For example, teaching. Now, teaching, you want to know the scores of your student. Where does it lie in the normal distribution? Teaching, research, finances. There are many more, no? So next slide is that the normal distribution. A symmetrical bell-shaped curve commonly used to compare scores in natural phenomena like IQ, height, and test score in large sets, most observation cluster in the center, with fewer at the tails, forming the characteristic of a normal curve. So based on the text I read, normal distribution is a special type of graph, no? So the graph looks like a smooth symmetrical bell shape that I will go into let you see in the next slide. So looks like a smooth symmetrical bell shape. It's one most common ways to show how things are like those are mentioned, how things are spread in large group of people. We should know that most people's scores in the measurement is near the middle or the average. Fewer people scores the low and high scores. And it also creates a normal, as it said, bell curve or bell shape. So, so this is also called as Gaussian distribution. Why was it so named after Carl Friedrich Gauss? So distribution has been used as a standard reference for many statistical decisions in the field of research and evaluation. So as it's the Gaussian, called Gaussian distribution. So it's the name of a famous mathematician who studied the pattern or the one who studied the normal distribution. So because it appears so often, in nature and research, scientists use it as the standard way to compare and understand data in a data set, no? In the next slide, we'll have in assessment, the area in the curve refers to the number of scores that fall in a specific standard deviation from the mean. The scores, in other words, each portion under the curve contains a fixed percentage of cases as followed. So we should know that a standard deviation is a way to measure how spread out the scores from the mean are. no? So we have 68, which means that all score fall within one standard deviation above or below the mean. That same goes to 95% and 99.77%. And the next slide, we can see how it goes. So the middle part of it was the 68%. The next part of it was the 95%, and the last part is the 99.77%. So this means that most people are in the average if it is falls into 68.26%. And as it said, most people are in the average and fewer have high or low scores, as I said in the previous slides. So the following figure illustrates the theoretical model. So from the figure, we can state that properties of normal distribution. First is the mean. Median, mode are all equal. So that means the mean, which is the average, median, the middle value, and the mode, the most frequent value are in the same number, right in the center of the curve. No, it's in the center, like if I write 0, for example. So the curve is, second is that the curve is symmetrical. As such, the value in a specific area on the left is equal to the value of its corresponding on the right. So the curve is perfectly symmetrical, which means the left side is like a mirror image to the right side. So the third reason of the following illustrates that the curve changes form the concave to convex and approaches the x-axis, but the tail do not touch the horizontal axis. So the curve never actually touches the horizontal line of the x-axis, but it gets closer and closer. For example, this is the horizontal line. This is not the curve. So it gets closer and closer, but it never touch the curve, no? So it 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 is the stretches in both sides of it. And the fourth one is that the total area of the curve is equal to 1. Why 1? 1, which means it represents 100% of the data. So Q&A time. So before the question and answer portion, this is the table of how the data fell in normal distribution falls. So, what are the defining characteristics of normal distribution? What are the defining characteristics of normal distribution? So there are many defining characteristics of normal distribution. The bell-shaped symmetrical curve center around the mean, median, and mode are all equal and located on the center of the distribution. So also we should also know that the curve is unimodal, which means it only has one peak. No, we haven't seen normal distribution with two peaks, aren't we? No, so it's continuous representing the continuous of random variable. So it never touches the x-axis in both sides. So it spreads. The spread of the distribution is determined by the standard deviation. No, a larger standard deviation makes the distribution curve wider. So it's like if the standard deviation is just an little or not a large number, it would be like the peak of A in the dispersion, measure of dispersion. If it is wider, like let's see, that means the standard deviation is large, no? So it follows empirical rule, the 68, 95, and 99.77% rules. Also, as I said, the curve is symmetrical, and the left and right are like a mirror image of each other. So in the next slide, we will have the standard score. So what is a standard score? A statistical measure that describe how far a particular value or raw score is from the mean of its group. Measured in units of standard deviation, it tells you how ma- many standard deviation above or below the mean a data point lies. This makes it possible to compare scores from different distribution by converting them into a common scale. That means, no, that means a score can be interpreted in the more meaningful way. If you know the mean and variability of of the other score, that means where the single score belongs, knowing the raw. So you already know the raw score, your raw score, and your classmates' raw score. So if you already know so if you calculate it, you can get the mean and the variability. So knowing it, now we can convert this raw score into a standard score if you know the mean and the variability of the overall scores in your classroom. So if someone asks, what is a raw score? So a raw score is like your score that is still not altered, no? It is an altered score, which is if your score is 15, and if you get the percentage, that means the percentage is an altered score na now. So the raw score is that what the score that you get or the grade that you get is still not altered by anyone. Okay, sometimes we treat our grades so that our parents wouldn't know that we are having a failing grades in a subject, So next is that this is the z-score, which is also known as the standard score. It's a statistical measure that expresses how many standard deviation a particular data point. Raw score is from the mean of its distribution. If the raw score is above the mean, the standard score is positive. If it's below the mean, the standard score is negative. So this z-score is like the formula of a standard score. And this is the first score you need to solve to get so that you can get to proceed to the transform score or t-score, is the 9 score or standard 9 score. So this also helps to identify the unusual or typical score is within a distribution, making them essential in various fields as they can interpret data, detect outliers, and compare results from different scales. So imagine if you took a test and you want to know how well you did compared to everyone else in your class. So just knowing your raw score doesn't tell you the whole story or the whole thing because maybe the test was too easy or maybe you just scored high. No, a Z score is here to help you know if you know if the test score is easy or maybe everyone just really scored high. So Z-score helps solve this problem by showing how far your score is from the average. Measured is in units called standard deviation. So this Z-score tells you how many steps you are away from the average score. So if this is the average score, how many standard deviation away are you? No? So if z score is in the positive, it means you scored higher. If z score is in the negative, it means you scored much lower than all of your classmates. So if z score is 0, that means you are at the average. So this score is exactly the average of the whole. So this z-score formula is that your score, this is your score, the x, no, minus the mean or the average score of a whole class over standard deviation. So standard deviation is measure how spread out the numbers in the data sets around the mean or the average. So we should know that standard deviation is already tackled twice in our class. First is teacher J in group 6 and teacher Joy in our group. He still tackled the standard deviation. So if you've forgotten the formula of standard deviation, this is the formula of standard deviation. If ever it is not given in the question, you can use the formula to calculate the standard deviation of this course, no? So in the figure, a score of 86 in English indicates better performance than the score of 90 in physics. Let us suppose that the standard deviation in English and physics are 3 and 2. That means English, the standard deviation in English is 3, while the standard deviation in physics is 2. So that we can express the raw scores as the z-score, as a z-score. So converting, we need to convert the score of 86 and 90 into a z-score. So we can see the graph of physics and English grades in the z-score, no, in the z-score graph. So this, you can see the figure 8, the comparison of score distribution with different means and standard deviation in the book, actually. So as we can see, the z we have here is ZE, no? The ZE, that means Z score of English. And 86 is your score. For example, it's your score, 86 in English. And minus the average or the mean 80 in the whole classroom over the standard deviation of 3. So you get 2. Well, ZP, that means P is physics, all right? So z-score of physics is 90 as your score, minus 95, which is the overall average of the whole class, over 2. You can already see that the average of the whole class, your score is much lower than the average, no? So if we divide it in with 2, we can get the negative 2.5. As if we subtract 90 over 95, no, we can get negative 5. Oh, divided it by 2, we can get negative 2.5. So this is the z-score of the both score. This is the figure 8.9, different row scores in one z-score distribution. We can see the difference of between the scores. So if it is in the positive, that means you get higher than the average. While if you get the negative, that means you get lower than the average. Now, let me drink a water. So t-score. We are already in t-score. So a type of a standardized score used to interpret test results, and it is also known as transform score. If a z-score is a repeating or non-repeating decimals and have a negative in it, may not be understandable for others. One of the options is to convert z-score into t-score, converting standard score into transform score. So there is a scaling of z-score to t-score. So the mean of 50 and a standard deviation of 10 makes the scores easier to interpret. Also, it avoids negatives and decimal number, placing the average at 50 instead of 0. So t-score is typically always positive. No, it doesn't have any negative, but it has decimal points still. So because they are standardized score, transform score has to have a mean of 50 and, as it said, a standard deviation of 10, which sweeps the scale from negative into positive, no? So that the negative value would not pure, and sometimes decimal also, but not the non-repeating decimals only. But those repeating decimals that is still inside the t-score, no? So it's like, so as you can see, the negative and the decimal of the physics, which is negative 2.5, is already gone when it is converted into t-score. But the English makes higher. So the t-scores formula is equals to 50 plus 10 times the z-score. So 50 plus 10 times negative 2.5. So 10 times negative 2.5 makes it 25. So there is a negative. Well, 10 is positive. So it will become negative. The sign, I mean. So 50 minus 25 is 25. If you input this, the 50 plus 10 times negative 2.5, you can always get 25 in your scientific calculator. So in English, 50 plus 10 times 2, which makes it 20, plus if you plus it with 50, it will be 70. So in here, I just let you see how the process is, no? But if you put it in your scientific calculator, you can get that score. Let me show you. I mean, let you see it. I'll let you see in the screen. So 50 plus 10, open parenthesis, negative 0.50, close parenthesis, and equals, you can get, or you can get 25 actually. You can use, when you use calculator, you can see get the scores, no? The answer, I mean. So here in this slide, we can see that the z-score has a repeating decimals. So it will lead the t-score into a repeating decimals as well. So the repeating decimals here is 2.333 and 0.555. So if you convert it into t-score, no? Why is it not rounded up at the bottom of it? So let's find out in the next slide. So it's like that. So why should we not round up the decimal into a whole number? Why? So even though the decimal is 5, you can convert it into 56 instead. And if 73, you can round it down, round up in the 5 and round down in 3. That means 73 only. So why should we not round the decimals into a whole number, no? So rounding a t-score into a whole number makes it not accurate and precise of the measurement. Since t-score is designed to provide a standardized and sensitive measure of performance, even small decimals differences can be meaningful in t-score. So rounding off this decimal places can mask subtle but important distinction between the individual scores. So therefore, we need to maintain those decimal places, no? But most importantly, to maintain the both clarity and accuracy of it. There are a recommendation in it, no? So that the t-score will not be crowded with numbers. We can convert it into one or two decimal places. For example, 73.3333 and 755.656 or 55.6 or 73.3, no? So this is recommended as this practice preserves the detailed information of the score, no? It didn't provide an overwhelming or an unnecessary digits already when you convert it into one or two decimal places. Now we are in the ISTA-9 score. Why is it called ISTA-9? Let's find out. So this standard score is another standard score shortened from the word standard 9 score. With 9 in its name, the score are on a 9-point scale, just like T-score. The 9 score can be calculated from Z-score by multiplying Z-score by 2 and adding 5. No? So is the 9 score is a way to simplify and standardize test results by grouping them into one of 9 categories, numbered scale from 1 to 9. So from the word sta9 comes from standard 9, meaning the scores are 9 parts. So 9 parts, where is it? Okay, where is it? So sta9 score, the assumption that sta9 scores are normally distributed, the percentage of cases in each band and or ranges of scores in the following scales as follow. So the sta9 score is a way to show or tell how well someone did on a task by putting their score from 1 to 9 simply by the sta9 actual that is actually from standard 9, and this is the following scales. No, most students get the 4, 5, and 6, which is the average, while 1, 2, and 3 is lower than average or below. So 7, 8, and 9 is higher than the average. We should know that is the 9 score is broad. Why would you call it broad? No? Because it reduces the detailed information into larger and much less precise categories, no? Making it like easier to interpret at a glance, but it is less useful for fine distinction between individual performances or your students' performance, as be as we can see in the table, it simply arranged the sta9 score into lowest to highest. So with the following percentage that is directly assigned in an appropriate sta9 score. That is why sta9 is broad, as even though you have different score. For example, your score is 9 and her score is 7, but you have the same sta9 score falls into sta9 score 8, which is 70% high, a high percentage of score. No, you can it as it falls into the same sta9 score, you will have the same percentage, which make it more broad, as we cannot see the difference between two scores of the students or the performance. That's why sta9 score is a bit useless, no? But we cannot call it useless because many people are still using this, but its usefulness is not that much with the T-score and Z-score. So this is the sta9 score of physics and English. So the English has 9, while the physics has 0. So 0, that means Frederick scored lowest. No? As we can see, 2 times negative 2.5 is negative 5 plus 5. That means 0. So 2 times 2 plus 5 means 9. So 9 is the highest. That means you get highest score in your test. While in physics, you get lowest. And not just lowest, your score is not even in the sta9 score. So no? So this is the table about the scores of English and physics on the following standard score. We can see that in the Z, who your score in English are the following: 2, 70, and 9. While in the physics, negative 2.5, 25, and 0. 0, it's already beyond the number 1. No? So this is how the normal distribution of the following scores. we can see that your score was never full in physics. If you use a Stanine score, your score was not even full, isn't even full into the 99.77% of the scores. It's in the other side of it, which makes it lovable for me, no? But in English, you get 2 and 70, which falls into the 95% of the score, which is higher than the standard score as it is in the positive area, higher in the 68 or the average score because it's in the positive area. And the your standard 9 score it falls into the 99.77% of the scores, which is at the positive side. So your score in physics was in negative 2.5. That means in between, also 25, it's in between the 97.77% of the scores, and it falls in the negative area. Well, in the standard 9, your score is 0. That means it didn't fall into the 99.77% of the score. That's quiet, not right. No? That's why its standard 9 is not useful in getting an accurate and precise score or precise distribution of the scores. Next, we have here the practice exercise. I will going to send this into the GC. So I will going to get your papers. I am expecting it on Monday. No? This is a practice exercise to know if you already learned how to get the mean, standard deviation, the z-score, t-score, and standard 9 score. So Q&A. How does t-score differ from the z-score? No? When they are both standard score. Sorry, napiyok. So z-score and z-score are both standardized score used to determine how far a data from the point of the mean or the average in measured in standard deviation, but they are used in a different situation. You know, z-score makes the population of the mean and standard deviation, like the sample size. Like for example, the sample size is 100, but your z-score is low. Like it makes the sample size much much smaller. While in t-score, a smaller sample size, like for example, your score uh, is 2, it will make your score transform into a bigger value. While in z-score, smaller value, it makes your score a smaller value. What in z-score, it makes your score a larger value. No, in summer, that's why the difference between the both of them. And also the t-score uses the z-score, and the z-score use in its formula the raw score and the standard deviation. Now, while t-score uses the z-score and the mean of 50 and standard deviation of 10. No? So the next slide would be, so why are standard scores useful in testing? So a standard score like z-score and t-score are useful because they allow you to compare results in the different tests or distributions on a common graph, common scale. They show how far an individual scale from the average, no? So it can be easily interpreted whether your score is above or below the average by how much it is in the following formula. So a standard score helps you identify the outliers, comparing the performance scores of different groups or different students, making a fair decision in education, psychological, and medical testing, also in research as well, finance. There are many use of them. So they also enables researchers and practitioners to use the statistical table. So you I never show you the statistical table of z-score and t-score, but you can find it online. And if I am right, this is already lesson to you by your instructor in senior high in statistics 4006 statistics, no? So they have already you have already learned it from them how to use c-score and t-score tables. So this also why z-score and t-score is useful, is to determine the probabilities from that table and make inference about the population from a sample data. So I will flash you the table of the z-score and t-score for a bit. Going to share a bit, but I will go here. So I will going to flash it in you guys. No? A minute. I will flash the z-score and t-score table and you. So here is the z-score. If you can see it in your screen, am I right? This is the z-score table, which you can find, for example, your z-score is negative 2.5. Here is it. No. Here is negative 2.5. That is where you are going to find how far your score from the standard deviation. So negative 2.5 and the standard deviation is 2. I am right. So this is the only table I have because my table, the z-score and the t-score table that I have in senior high, I already deleted it along with the other files. I forgot to save it, no? So this is the t-score table. This is the t-scores and the z-scores will have. So for example, one tail. So where is the 890, 870? So it falls in here, 0.25. And your z-score was 2. That means it's 0.816 in the t-score table. That's all for today. Got this video, guys. I hope you learned many things in this video, and thank you for listening into my lesson. I see you guys in our online and face-to-face classes. Love you all. Bye.